Welcome to this demonstration on how to work out or calculate a standard deviation. So if you look at what's in front of us, we have a set of scores, and that's our starting point for working out a standard deviation. Now, the first thing we need to do is work out the mean of this set of scores. So we have 10 participants, and those are their scores: 4, 6, 5, 4, 1, 3, 2, 4, 7, and 4. So the first thing we need to do is work out the mean of those scores. So I'm going to put that just here. And I'm going to use a formula to help me do that. So basically, this formula is adding up these scores and dividing them by 10. And the mean is actually 4. So I'll put that in a different color. So add those together, it equals 40, divided by 10 gives us a mean of 4. And so what we need to do is take that mean, okay, which is 4 all the way down, and subtract the mean from each of the original scores. So 4 minus 4 obviously gives 0. The next one is 6 minus 4, so that score is 2 above the mean. 5 minus 4, that score is 1 above the mean. Those scores are equal. Participant 5 scores 1, so they are minus 3, okay, so 3 below the mean. 3 minus 4 is minus 1, 1 below the mean. 2 minus 4 is minus 2, 2 below the mean. No difference. 7 minus 4 is 3, and no difference. And what I can see is that those scores add up to 0. So minus 2, minus 1, minus 3, okay, is minus 6, plus 1, plus 2, plus 3 is plus 6. So they add up to 0, which is what you want to happen with your differences. Now, to get rid of those negative numbers and to stop them adding up to 0, we square each of these differences. So 0 squared is still 0, 2 squared is 4, 1 squared is 1, 0 squared is still 0. Now minus 3 squared is 9. Minus 1 squared is 1. Okay, because minus times a minus equals a plus. Minus 2 squared is 4. Then we have 0, 9, and 0. We still have the same pattern of differences. So for example, participant 5, who scored 1, is the most different from the mean. Okay, he or she is 3 different from the mean. When you look at the differences squared, okay, the biggest ones are 9 here and also down here, because participant 5 and participant 9 both have the scores which have the biggest difference from the mean. So participant 9 is 3 above the mean, participant 5 is 3 below the mean. Where there is no difference, like with participant 1, that stays the same when the difference is squared. Okay, that 0 is still there. What we need to do now is add up these numbers. Okay, it looks quite easy, but I'll cheat and do it this way. I'll get the spreadsheet to do it for me. Just want to add up those. Let's try again. Add up those. The total is 28. Okay, so the sum of the differences squared is 28. If we do anything with this 28, we need to come across here and work out what n minus 1 is. Now, n is the number of participants, take away 1. So there are 10 participants, we subtract 1, so n minus 1 is 9. And then the next thing we do is we take that 9, just give me that different color. okay, and we divide the sum of the differences, 28, by 9, and that's the next stage of our calculation. So the sum, 28, divided by n minus 1, 9, is, so I'm looking for that 28 divided by that 9, which gives me 3.111111, and so on. Now the final stage is to square root that. Okay, so we need to find the square root of 3.1 recurring. So I've got a formula for that. Square root of so let's go back one. Let's get that right. So I need to put in there, sorry, I need to put back in there that 28 divided by 9. So let's do that again, sorry. There is 3.111 again. So this is where we need to put the square root. That was my mistake. So that's equal square root that number there. I should get the answer. Yeah. So if you square root 3.111111 recurring, then you get this answer here. Okay, let's put that in a different color. Let's go for purple this time. Now that square root, okay, is actually also the standard deviation. Okay, so for right here, standard deviation. What I'm going to do, I'm just going to take it to 2 decimal places. So 1.76. And we'll highlight that. So we've worked out the standard deviation. So just to remind you how we've done that, we started with the scores and we worked out the mean. That's that 4. We subtracted the mean from every score. And that gave us this set of answers, the differences. Now these differences will always add up to 0, whatever the data set. So what you then do to stop that happening is you square the differences, and when you add those up, you will get a number which is not 0. In this case, you have 28. You then work out n minus 1, which was 9 on this occasion, and then we do 28 divided by 9. Okay, the sum divided by n minus 1, and that gives you, in this case, 3.111 recurring. The final step is to square root that 3.11111, and that gives us 1.76 to 2 decimal places. So we call that the standard deviation. And what that's telling us is that the majority of scores deviate by 1.76 either side of that mean. Okay, so the majority of scores go up to 5.76. That was possible, so 5 to 6. Or below that, okay, down to 3 or 2. And that's true because most of the scores are 2 or 3 or 5 or 6, with just a couple of them, the 1 and the 7, being outside that standard deviation. So remember again, that standard deviation of 1.76 tells us that most scores, on average, are 1.76 above the mean or 1.76 below the mean. And because that standard deviation is low, because 1.76 is low, we know that most scores are close to the mean itself. And again, we can see that, okay? There isn't a great range of scores here. Most scores are close to that mean of 4. We'll talk more in another video about how we interpret standard deviations. The important thing to understand from this video is how we have worked out or calculated a standard deviation. It may be something you have to do in the exam. Hopefully you'll get a simple data set like this if you had to do it. So just make sure you're clear on the stage as you go through. And as always, be careful with your maths. Okay, thank you.